Good day, guys, and welcome to this lecture. In today's lecture, we are going to be discussing the concept of simplifying surds. In our last video, we discussed an introduction to surd, and we said surd is the square root of a number that is not a perfect square. A surd is the square root of a number that is not a perfect square. And we also established that a surd is an irrational number. Irrational number meaning that it has lots of decimal numbers after the point. In today's class, we're going to be discussing how to simplify a surd. But basically, I'm going to be explaining how we can split up a single surd. So I will advise you stick to this video and watch the video to the end of the class. Let's have example 1. We're asked to simplify surd 18. We're asked to simplify surd 18, surd 27, surd 54, and surd 147. Now, these are different questions, right? I'm going to be treating them one by one. So for the first question, we asked to simplify surd 18. Now, when you are simplifying a surd for this single number here, we are going to look for two numbers that multiplies to give us 18. Two numbers that multiplies to give us 18. Let's start from 1. 1 times 18 is 18, right? 2 times 9 is 18. 6 times 3 is 18 as well. I think that's all. These are all the factors, right? Or 3 times 6. Is either 6 times 3 or 3 times 6, whichever way. So out of these are factor pairs of 18. This is a pair, this is a pair, this is a pair. So within these three pairs, which of these pairs has a perfect square? If you look at the first pair here is 1 and 18, right? We can't use this one. We can't use the first pair, right? We can also use the last pair. Now, why can't I use the last pair? Whenever you are simplifying a surd or you want to split up a surd, you are to use the pair that has a perfect square in it. So for this one now, the first one does not have a perfect square, and then the last one too does not have a perfect square, right? So the only one that has a perfect square here is 9. So that's why I'm going to use this man here. So which means I'm going to replace that 18 with 2 times 9. So I'm having surd 2 times 9. And if you're with us in the first class, we said when we have surd A times B, we are free to split up the surd. So we have surd A times surd B. That is if the sign is a multiplication sign. So applying that here, this is going to be surd 2 times surd 9. Are you seeing that? When this is done, 2 is not a perfect square, it's a surd. So we're going to have surd 2 multiplied by, this is a perfect square, and square root of 9 is 3. So we multiplying these two together now is going to give us 3 surd 2. And this is our final answer for this. So for the second one, I'm having surd 27. Surd 27. Right? Without wasting time, I know that the two numbers I need to multiply to give me 27 are 9 and 3. Because 9 is a perfect square. Right? So I'm using 9 times 3. Are you seeing that? So applying the same principle from example 1, this is going to be surd 9 or square root of 9 times surd 3. And square root of 9 here is going to be 3 times, this is not a perfect square, so we'll leave it in this form. And when you multiply this together, you have 3 surd 3. And then for example 3, we have square root or surd 54. So what two numbers multiply together to give us 54? we can use, let's start from 1. 1 times 54 is 54. 2 times 27 is 54. And 3 is a factor, so 3 times 18 should give us 54. Okay. I don't think 4 is a factor. 5 is not a factor. 6 is not a factor, or 6 is a factor. So 6 times 9 is 54 too. 54. Okay. You see, I'm looking for the factors of 54. That's why I'm doing this. 7 is not a factor. 8 is not a factor as well. So I think that should be all. So now between this pair, this and this, which of them here has a perfect square? We can't use, obviously we can't start from the first pair, right? It's ruled out. Now between these 3, which of them has a perfect square? This is not a perfect square. 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 This is not a perfect square, and this is a perfect square. Are you seeing that now? So that means I'm going to use this guy here. Do you understand? So applying that here, I'm going to use 6 times 9. Square root of 6 times 9. And when I separate this, I'm going to have sod 6 times square root of 9. Sod 6 is not a perfect square, so I'll leave it this way. Multiplied by sod 9 is 3. And when I combine this, when I multiply them together, I'm having 3 sod 6 as my final answer. Then for the last question, I have sod 147. Sod 147. Now for this problem, I'm going to look for 2 numbers that multiply to give me 147. That is, I'm going to look for all the factors of 147, right? So starting from 1 times 147 is 147. I've used 1. Let's try 2. I don't think 2 is a factor of 147. It's not. 157 divided by 3. Okay, 3 is a factor. So 3 multiplied by 49 is going to give me 147. 4 is not a factor, obviously. 5 is not a factor. 6 is not a factor also. 7 is a factor, and that's going to be 7 times 21 gives us 147. Are you seeing that? 8 is not a factor. 9 is not a factor. And we keep wrapping around. So which of these pairs now gives us, among which of these pairs do we have a perfect square? Obviously we can't use the first pair. You just know that you can't use the first pair. So between this pair and this pair, which of them is a perfect square? So between this and this is not a perfect square. This is a perfect square. This is not a perfect square. This is not a perfect square. So we can't use this, and we can't use the first one. So we are using 3 times 49. It means that we are going to replace this sod 47 with 3 times 49. And when you split this up, you have sod 3 times sod square root of 49. This is going to be sod 3 times square root of 49 here is 7. And when you combine this together, you have 7 sod 3 as your final answer. Let's look at more examples. Let's look at the second example. We have to simplify all of these questions we have here. First question 1, we have sod 18 plus 2 sod 2. Let's have the solution to that. Sod 18 plus 2 sod 2. Alright, so for this 18 now, what 2 numbers multiplies to give me 18? Are there 2 numbers that multiply to give me 18? Yes, 2 times 9 is 18. 2 is not a perfect square, but 9 is a perfect square, so I can use this pair to replace this guy here. So for this 18 now, I can use I can use this guy, 2 times 9, that is to replace 18, plus, and then this guy here, 2 is just a single number, there are no two numbers that multiplies to give you 2 that any of them is a perfect square, right? So I'm going to leave this guy in this form since it's just a single number here. So I'm having 2 surd 2. But don't make a mistake. Assuming I gave you 2 surd 8, for example. Let's assume I gave you 2 surd 8. Don't say because this is a single number. You ask yourself, are there two numbers that multiplies to give you 8? Of course, there are two numbers that multiplies. 2 times 4 gives you 8. So among these two numbers now, which of them is a perfect square? Of course, 4 is a perfect square. So for this one now, I'm just having 2 surd 2. There's no number that multiplies to give me 2 that's a perfect square. That's why I left it in this form. That's why I left it in this form. Do you understand? All right, let's continue our solution. So from here, I can decide to separate these guys, these two, using one of the laws of surd. So this guy here is going to be surd 2 times square root of 9, that is for these 2, plus 2 surd 2. And then this is not a perfect square, so I'm leaving it this way. So 2 multiplied by 3, then plus 2 surd 2. So if I multiply this together, these two, I'm going to have 3 surd 2 plus 2 surd 2. So this multiplies this to give me 3 surd 2, then plus this one here. So actually, this whenever I told you that whenever you are adding a surd or subtracting a surd, you consider the number inside the root. So if they are the same numbers, it's a like surd. If they are different numbers, it is an unlike surd. So this is a like surd. Why is it like? Because I'm having 2 inside here and I'm having the same 2 inside here. So I am free to add the coefficient, that is 3 plus 2 gives me 5, then surd 2. So I leave it in this form. That's the final answer for question 1. And for question 2, I'm having surd 12 plus surd 48. Surd 12 plus surd 48. Now for this one here, what two numbers multiplies to give us 12? Those two numbers are 4 and 3. That's for this. Then for this one, what two numbers multiplies to give us 48? That one of them is a perfect square. I think that should be 16 times 3. Right? Because I use 16 because 16 is a perfect square. So if you check it, 16 times is going to give you 48. So if you separate these guys using the laws of surd, this is going to be surd 4 times surd 3 plus surd 16 times surd 3. So if you work on this guy, this is going to be, the square root of this is 2. So we have 2 surd 3 plus 4 surd 3. So they are like surds. So when you add these two together, you're going to have 6 surd 3 as your final answer. Alright, for question 3, we have 5 surd 6 minus 2 surd 3 minus 2 surd 6 plus 4 surd 3. So for question 3, I'm having 5 surd 6 minus 2 surd 3 minus 2 surd 6, then plus 4 surd 3. In this case here, there are no two numbers. I'm working with the number under the root. So in this case, there are no two numbers that multiplies to give me 6. So I'm leaving this in this form. 5 surd 6, and I'm collecting like terms. So this adds surd 6 inside. This also adds surd 6. So I'm collecting this and this together. So I'm having 5 surd 6 minus 2 surd 6, then minus 2 surd 3, then plus 4 surd 3. Why I did here is, since under the roots I'm having single numbers, right? And there are no numbers I can multiply to give me 6. Now one of them is a perfect square. Same with 3, same with this 6, same with this 3. So what I have to do is to collect like terms. Collect like terms because I'm having a plus and minus sign there. So this and these are the same. So 5 minus 2 gives me 3 surd 6, and then minus 2 plus 4, that gives me plus 2 surd 3. And if you notice carefully, I cannot add these two together. Reason is because they are unlike sword. So I leave my answer in this form. And for the last question, I'm having 3 sword 48 minus 3 sword 48 plus 192 plus 3 sword 12 minus sword 147. So let's have that. We have a 3 sword 48 plus sword 192 plus 3 sword 12 minus sword 147. Now for this guy here, ignore the 3 outside here, this 3, then simplify. What number multiplies to give you 48? That's 16 times 3. Behave as if you didn't see this 3, I mean the 3 outside here, leave it out. Then you have 16 times 3. Are you seeing that? I expressed 48 as this. Then plus this guy, what 2 number multiplies to give us 192? Okay, let's try 16. Okay, we can't try 16. Let's try 192 divided by 2 gives us 96. 192. So what I'm doing is 1 times 192 is 192, right? I'm looking for the factors now. Then 2 times 96 will give us 192, right? Let's try 3. 3 times 64 will give us 192. So I think we've gotten the number already. We can't obviously use this first pair. So between this and this, I can only use this because this is a perfect square. This is not. So I'm replacing this 192 now with 3 or 64 multiplied by 3 or 3 times 64, whichever way. Then I'm having plus, ignore the 3 outside here. Then you have 2 number multiplied to give you this, that is 4 times 3. Are you seeing that? Then minus, what 2 numbers multiplies to give us this? That should be 49 times 3. I think we've worked that out somewhere. So for this guy here, this will be 3 outside, then multiplied by, now where did I see the multiplication sign? That is the sign in between the 3 and the root, that is the sign in operation here. The sign in operation here is a multiplication sign, right? So 3 times, if you work on this man, this is square root of 16 times, so 3. I just separated these 2. Then plus this one, square root of 64 times, so 3. Then plus the 3 outside here multiplied by square root of 4 times, so 3. Then minus square root of 49 times, so 3. So I just separated each of them. So this one here is 3 times square root of this one is 4 times, so 3. That is everything here. Plus this one here is 8 times, so 3. Square root of this is 8. Then this one. Then plus this is 3 outside already. Multiplied by square root of this is 2 times, so 3. Then minus square root of this is 7 times, so 3. So if you multiply all this here together, 3 times 4 is 12. So we have 12, so 3 for this guy here. Plus this is 8, so 3. Plus this is a 6, so 3. And minus 7, so 3. So what do you observe? Each of them are having so 3, so 3, so 3, so 3. They are all like so. So you can simplify all of them together by saying 12 plus 8 is 20. 20 plus 6 is 26, and 26 minus 7, that's 19, so 3. And that's the answer to that problem. Thank you for watching, and see you on the next one.